Yeah, this paper's called GPTs or GPTs. I'm going to talk about what we did in the paper primarily, but I'll also kind of go off script a little bit and talk a little bit about what we're seeing overall in this space. So when I say GPTs or GPTs, as Amir alluded to, what we're saying is generative pre-trained transformer GPTs are general purpose technologies GPTs. So the former is our CS GPT, the latter is our economics one. And we're kind of blending these two areas, trying to answer kind of two questions at once. The first question is the big one that people have been wondering about. Are AI systems going to negatively impact people at work, as we automate a whole bunch of stuff? But then there's the second question, which is, if large language models and I guess generative AI or AI in a broader sense are general purpose technologies, that means they change a whole lot in the economy, and lots is required to unlock their gains. So if that's the case, then it's really hard to say right now what the long-term equilibrium is going to be, where things are going to settle as supply and demand move around. So by testing whether or not these technologies are general purpose technologies or show the characteristics of general purpose technologies, we can kind of limit what we have the ability to say at this moment. So from a labor market perspective, this is an optimistic paper. I'm going to tell you right now, I don't think there's evidence and massive automation from these technologies. I think there will be some displacement, but it kind of rhymes with older technologies. So that's the optimistic piece. Of course, something can change. We could see a massive advance somewhere in the near future that causes us to have to reevaluate. I'll talk about that a little later. On the other hand, though, there is a little bit of pessimism here because we're just limited in our ability of what we can say about how things are going to change. So this is a way of trying to rigorously test that thought. Like, do we have to wait and see, and what kind of implications does that have? So I'll say right now that like IT-based job displacement stuff is by no means new. We've had this panic many times before, and it seems like every single time, at least some in the press are promoting it. The last wave did work, though. We shifted away from routine cognitive and routine manual work towards more non-routine, especially non-routine cognitive work. If you want to do something entertaining, go on YouTube, look for videos of offices in the early 90s or late 80s, and you'll be surprised at the kinds of things that people do or did. Then we don't see as much of that type of work now, but we do have tons and tons of office work, obviously, and things have changed. So we might want to think about, well, how might things change from the perspective of generative AI. So what this paper does, and what we're going to do and discuss today, is first we develop a new way of evaluating if tasks in the economy are exposed. And that's a loaded sentence. Let me break down a couple of things here. So a job you can think of as a bundle of tasks. I actually think the job level analysis is you're looking at jobs is usually the wrong unit of analysis. You either want to look at things that people do in their jobs, the tasks, or you want to go higher level and think about systems. So if you're going to break apart an entire system, install afterward is going to have different demands. So different mixtures of jobs, different mixtures of what people do, or you can look at what people are doing specifically and think about where can I deploy technology. So when we say exposure, we're going to look at every one of the tasks that people do in the US economy. There's a long list of them that the US government puts out. And we're going to think about, all right, where is there opportunity to change how people are doing things with large language models? So exposure is neither good nor bad. It could be augmentation, it could be automation. Automation can be both good and bad for workers. It really depends. So, what we're trying to identify here is a potential for change. All right, so, that potential for change, what are we looking for? One, let's define a general purpose technology. A general purpose technology in economist terms has three main characteristics. The first is that it's pervasive. It's going to affect lots of different types of roles and lots of different contexts. The second is that it's going to improve over time, that the technology gets much better. And then the third is that it both spawns and requires complementary innovation. And when I say that, I mean, it's the training, it's the business processes. There's intangible co-invention that needs to be done alongside the technology. We're already seeing software-based versions of that with, say, retrieval augmented generation, or some of the chatbot stuff, or any of these different techniques to make large language models perform better in context. That's sort of complementary innovation. And we're going to test for these three characteristics. And we can say that large language models are general purpose technologies, then we're also kind of in this bucket of, okay, lots is going to change, but we have no idea where the eventual outcomes are going to be because there's just too many missing pieces. We're not testing that hypothesis. Our algo is going to take away all of our jobs, but we kind of get that one for free because we don't see evidence of that. So the punchline here, about 80% of workers have maybe 10% of their tasks exposed. So really that all the work is going away based on what we've seen so far. Past general purpose technologies included things like electricity or steam power. There's also, the semiconductors and personal computing. Periodically, there's arguments made that cloud computing is general purpose technology, but it tends to be sort of localized. You want to think about pervasiveness. You want to think about complementarities being important, and then you want to think about researcher and technologist productivity too, but I'll get into that in a bit. So I'm going to punt on the middle thing though, where it's improving.
Daniel, very quickly, you can ignore the questions in the chat. We'll come back to them at the end of your presentation.
Oh, sure. Okay, can do. All right. So when we talk about improving over time, I'm going to punt here. I will not. I think this is something that everybody here is well familiar with. In 2014, we're getting variational autoencoders making images like this grainy face picture. At the time, I was stunned by that. I thought that was so cool. And now people are upset if your, photorealistic picture of a person has 6 fingers or something like that. So, we're kind of like getting frog boiled here. Slowly, the temperature is getting turned up. But I think it's kind of intuitively obvious that these models are getting better over time. So we're going to skip through there. And I'm going to talk about what we did here. So we've got, from the US government, this great database called ONET. So ONET is, put out by the US Department of Labor, and it has this nice tree structure to it. So we've got about 1,000 occupations. Occupations look like acute care nurses or computer systems engineers and architects, blockchain engineers in there, which makes me laugh, but it's a job. Then within those thing people do, but it's generalized enough that it can be shared across different types of workers. So like gambling cage workers and online merchants both execute financial transactions or execute sales and other financial transactions. That's a really general abstracted way of talking about what gambling cage worker might do, which would be like cash checks and process credit card advances. On the other hand, an online merchant would like deliver an email confirmation. And that's that more specific job specific version of a detailed work activity. That's called a task in the ONET taxonomy. So there's about 20,000 of those. And what we're going to do is go through each of those 20,000 different tasks and evaluate it using this rubric for its exposure to large language models. And that will give us a sense of pervasiveness. And we're also, as we'll see, we're going to talk about how that helps us evaluate the complementary innovation piece. So we're going to ask a really simple question, and there's only a couple answers to it. And that question is, can you cut the time it takes to do this task in half by using a large language model? All right, and I should add, with no drop in quality. Now, this is a technical question. It is not a social or political or organizational question. That does not mean that it may be appropriate to do this. It's just asking, is it possible? And we're going to evaluate that with both people, experts at OpenAI and large language model technologies. These are not experts in doing the task, but they know well what large language models can do. And then we're also, we also did a whole bunch of these. And then we're also going to ask GPT-4, and we're going to see how those two agree. And I'll talk a little bit about what happens there. But there's 3 answers to that question. Can you cut the time in half? First is no, like there's no exposure here. Sorry, I'm flipping burgers. Like large language model ain't helping me flip burgers, at least not yet, right? Then there's another version of that, which is, yeah, sure. So we call the former category no exposure E0, exposure 0, and the latter category, exposure with just large language models right out the gate, E1. All right, and then in between is this like, yeah, but it kind of depends. So for sure, I could conceivably use large language models in this task, but I need additional software innovation in order to unlock that gain. Now, if that's the case, then we think there's a bit of a lag, right? Like it's not going to be super, super easy for us to immediately go and deploy large language models into this task. We need some sort of software complement. Now, the software complements that additional development to help the large language model unlock its capability is a really limited version of code investment. And the reason we picked that limited version as opposed to saying, not only do I need that, but new training, I need a new business process around that, I need new software, all this additional stuff, is when you look at just the software component, if we see the need for innovational complementarities, then we can bolt it into all the other great research people have done, showing that additional software requires all those additional big time investments. So hiding in that software complement piece is actually a full range of really interesting additional complements, because we know from 30, 40 years of research that software requires really big changes in order to get it to work properly. So when we go and evaluate all these different tasks, these are at the occupation level that you aggregate up. Humans in GPT-4 tend to agree. This is a bit surprising to me. We did one as a robustness check of the other. GPT-4, if anything, is a little bit conservative in some cases. Humans have a little bit more vision about what large language models might do. So that was kind of cool. These graphs are the same, by the way. One's just the bin scatter of the other. So as your human rating goes up, your GPT-4 rating tends to go up too. I originally trusted the human ratings a little bit more, but now that I think GPT-4 might have more context on, like, say, what nurse tasks really are than large language model people. On the other hand, large language model evaluators may know a little bit more about their technical capabilities. So what do we find here? Well, about 15% of tasks, a little less, are exposed at the E1 level. That is, large language models can help right out the gate. And then if you're a little bit more expansive and you include exposure from these software complements and other things that people might need to do to unlock the capabilities, then you get to about 46% of tasks, which is a massive difference. You're way more limited in terms of what you do, and there's also diversification within jobs. There's maybe 20 to 30 tasks that people have. You're not limited to just one or two. Now, in the real world, there are jobs where people only do one or two tasks. So, Amir, I know you told me to ignore the chat, but you preempted where I'm going here. When you look at who's the most exposed, we have, I get a lot of angry emails from mathematicians saying we're not exposed, but yes, they are. And I've seen people using GPT to help them with their math. It does not replace mathematicians by any means, but it does help get rid of some of the tedium that they deal with in their daily work. On the other hand, interpreters and translators are highly exposed. No shockers there. On the other hand, you probably don't want the UN interpreters getting replaced by GPT or something, because then if something gets translated poorly, it can have global consequences. On the other hand, if I'm wandering around a country that where I don't speak the language and I just stick some stuff into Google, it's no big deal if I get it wrong. All right, so poets and lyricists, they're also exposed. I've met a poet. She does really cool spoken word work using large language models, so it's not even bad news for them necessarily. So we see this list. Here's the most exposed people. Mathematicians are really high. We've got proofreaders and copy markers, blockchain engineers. There's a lot of technologists who are highly exposed, and there's also a lot of clerical workers. So there's something important in that difference. I'll get to that in a minute. All right, so quickly now, before I go into the rest of the results, I want to say that there are huge and important caveats internal to the study that are big weaknesses here. And one of the kind of goals of our paper is to highlight the weaknesses of this generalized approach. There's a literature, I've been in this one for a while, kind of starts with Frey and Osborne. If you guys remember that paper, they said 47% of work is going to get computerized, within roughly 15 years. We're about 7-8 years in, and that hasn't happened. So, things to think about when you look at what's going on here. We've got subjective human judgments. These are people who understand large language model capabilities, but they don't know the roles super deeply. We're measuring large language models with GPT-4, which means you have to do the testing with the prompts, and you need to be really careful, trying different prompts and making sure you're getting high quality answers. Then there's the fact that these technologies can change a lot over time. So we don't have great human annotator expertise, in all cases, but they're not bad at evaluating what these models do. Now, that doesn't help you if the large language model changes a ton in the next few weeks. So, I mentioned that we're not talking about the legal or social or political context here. That can be okay, but it's something you should have in mind while you're looking at these results. And then lastly, what I'm going to talk about is, this atomic unit of work being the task, and that's a big assumption. Okay, so you can go even deeper. You can say, for a robotics task, right? Like there's opening a box, but the atomic version of that might be like use your fingers to peel back the top layer of the box or something. We're making an assumption that ONET's got this, mostly right. We're not saying anything about creation of new tasks, which is a giant deal in the economy. I'm not saying anything about systems. So all of these things early on, other than to build measurements of where to look for change and where things are likely to be a little bit unstable. And for that reason, we want people to interpret our results with caution, just as we interpret previous work with caution. We're not going to be claiming like, yeah, here's the big wave of automation taking away people's job. We want people to deploy this with the usual engineering perspective, where like you go through and you think, what's valuable? How can I build something that helps people? How can I build something that generates value? That doesn't mean you're automating away all sorts of work. That'll happen in pockets, but it's not the end of the world. So with that in mind, here's why I think some people find this scary and why the press has kind of pushed some of these narratives. Depending, if you look at the relationship between our ratings and how many people are in a job, it doesn't really, there's not much of a relationship there. But if you look at increasing wages as you go up in the wage profile for a job, there's much more exposure, and it doesn't matter if you ask humans or GPT-4. So those are the bottom two graphs here. Higher wage jobs are more exposed. So human capital, things that people have spent a lot of time investing in doing, that's the kind of work that's going to change. And in some cases, I think their wages are going to go up. But it does scare people a lot when something that they used to do a lot and they spent many years learning how to do is something that they're going to have to learn to do differently. In some cases, they see what they were doing possibly being automated. But that story, I think I haven't talked with a lot of companies. I haven't told any one of them to just straight up trust large language models and leave their concerns at the door in terms of human in the loop. That's a recipe for failure right now. All right, so lots of different types of jobs across lots of different industries are exposed. So we can tick that box for its pervasive. We assumed the one on it improving over time. Now let's take a look at that complementary piece. All right, so if you look at just large language models, and I say, all right, I want half the job, half of tasks exposed. Well, with just large language models, it's like 2 or 3%. It's really not that many roles. Okay. And sorry if you can hear a dog growling in the background. He's a very sweet little chihuahua at my mom's place. So we've got this 2 or 3% of jobs have, maybe 40 to 50% of their tasks exposed with just large language models. But if we're really permissive and we say all that additional complementary investment software has already happened, we've already finished the project in a way and integrated it into new systems, what percent of jobs have, say, 40% of their tasks exposed? It's somewhere between like 35 and 45% of roles. All right, so that's massive change, but it's massive change after a long period of development with lots of difficult challenges along the way. We can't assume the can opener here, as economists like to say. If anyone doesn't get that reference, I'm happy to tell that joke later, but I won't waste your time with it right now. But by looking at that difference, saying that the difference is meaningful, that's suggestive of a general purpose technology, which is also humbling for us. That means we can't make large scale prognostications about what will happen. The work falls to all of you, the engineers and the builders, to bring about this change. And we know that you're careful and you're thoughtful about how you do this stuff, which means it's going to take time. It's not instantaneous. All right, so I talked about exposure a lot, which can be good or bad. It means jobs going to change. what about automation? We did build an automation rubric. We did want to look at just that question. When you do that, the top jobs you get are things like telephone operators, telemarketers, word processors and typists, payroll and timekeeping clerks, lots of clerical roles. We've got tellers. These are the places where we should be looking for automation. These are things that, yeah, you could have humans in the loop, but I don't know, we have to think about the elasticity of demand, as they say. If we drop the price by 20%, how much does the quantity of these people that we want to see, how much does that expand, or do fewer of them? I saw a really cool travel agent bot from a guy I know he's a travel agent for his side hustle. You post a picture of where you want to go, and it gives you an itinerary and suggests all sorts of stuff. He's doing a great business. He's a travel agent, so he's automated something in his job that he hates doing, and which is like collecting these preferences and trying to like extract this like really costly, what do I like doing, what's fun thing from his customers. And instead now he can focus on like the part he likes, which is let me tailor this plan to you and get you really excited about where you're going. So even automation might not be too bad, but there's a notable difference between the types of workers who are exposed to automation and the types of workers who are exposed overall. The top end, less scientific, less human capital roles. But I will say there's a positive correlation between our automation scores and our exposure scores overall. You'd expect that to some extent, but I think this choice that people put out there a lot, that we can pick automation or augmentation, that exists at the overall economy level, which is where 500 policymakers care. At the granular job level, where people are making choices about what they do in their job, you get both. So, certainly there's some cases where you only get one or the other, but in many cases you get both. People are going to have to just change what they're doing. All right, so, I don't want to spend too much more time here. I'm going to skip through some of this. I'm going to talk about this for 2 minutes because I think it's the most exciting result we have. And it gets to this complementarity thing. When you look at who the most exposed people are in the economy, at say the E1 level, I talked a little bit about this, but it's the scientists, the research and development folks, technologists, engineers, and teachers. And what's so exciting about that is that when you change those things, they create rippling downstream productivity improvements. All of these people are questions we can answer that don't make sense without these technologies. Images or text. The encoders being able to take unstructured data and process it and pull insight and information out of it, that's just a giant deal. So if the coolest thing we get out of this is chatbots, I'm going to be pretty bummed out. Like, I think everybody can do their job better when these technologies improve, because the researchers in your domain are going to get better at what they're doing. So I put the challenge to all of you to build these tools faster, to get them out there so that these questions can be answered, that we can start using large language models to deploy cures for cancer, like personalized antibodies. I talked with the researcher who's doing that, or to help regulate tokamak plasmas or something like Google did, in sort of a toy example. These are really cool things to do with AI, and they're kind of going to advance things for everybody else. So there's a whole bunch of robustness checks. I'm happy to answer questions about that. Before, I do want to say quickly, this is one of those situations where you don't need econometrics. When GPT-4 came out, it did focus all the software developers. This is up and to the right. This is like 3x the size in percentage terms on everybody going home for COVID and working on data science things for GitHub. We're seeing massive developer attention on all this stuff, and that bodes well for us solving these problems. We can't have the attitude that for all the problems that large language models have, we tried nothing and we're all out of ideas. So I'm really excited to see what the engineering community is building, and I'll kind of close out there. So things to know if you take away nothing from this. It's like, yes, 80% of workers have something like 10% of their tasks exposed. But the long-term equilibrium for a general purpose technology is very hard to know in advance. And we see pretty strong evidence that GPTs are GPTs. We're equilibrium long-term right now. It's like asking James Watt, pumping water out of mines with the steam engine, what's going to happen to the global economy because of the steam engine. He wouldn't know. He doesn't know. And when you ask engineers, to the community's credit, most people are pretty reluctant to say, I know what's going to happen. When you hear people say all the jobs are going away, it's not like there's not a good economic evidence for that. And then secondly, tasks and systems, that's where you want to think about stuff. Don't think about whole jobs. That's a bundle of whole different things that make sense to be bundled together in the old regime. Now we're looking at a new regime. New tasks are going to be bundled together. So think about what people do. And, if you can help a worker out, you can say, hey, use this to get rid of the things in your job you don't like doing, or to make you better at the things you do like doing. I think people get pretty excited, and this technology doesn't seem quite as scary. So I'll close up there, and let's get into discussion.